Well, welcome back. As we prepare to get into this lecture and lesson, the lecture is a little longer than the previous lectures, and so we might take a break in the middle of it. The practice is certainly longer, and yeah, it's an hour and a quarter, all right, just for your timing purposes. All right, we're going to look at the boot process for Oracle Linux 7, and we're going to explore GRUB 2. Oracle Linux 6, GRUB 1. All right, so there are some differences. The primary difference between 6 and 7 is that in 6 you had an initial process called init. Gone. Today we have a process called systemd. And so systemd will be the last half of this lecture. All right. We'll describe what is called systemd services units. Those are what you used to do with a service command. We'll do target units. We'll configure the rescue and emergency modes, and we'll perform a shutdown, suspend, and reboot operations. Now, I'm not so sure you want to suspend an Oracle Linux server running an Oracle Linux database. All right, that just doesn't seem to make sense to me. But we'll cover them. Let you see what you need to do. Even though Intel is working on a unified extensible firmware interface, UEFI, so Utah, Edward, Frank, India, UEFI, it's not in place yet. And so your computer probably still has a basic input-output system, BIOS. And when you turn the red switch, it does a power-on self-test. If the self-test does not successfully complete, the box doesn't boot. All right, that's the key. Once the post is successful, the BIOS then reads the master boot record, 512 bytes, okay, of GRUB 2 information that allows us to boot your box. It loads the VM Linux kernel image, and then it extracts the contents of an init RAM disk image. The kernel loads the driver modules from the RAM disk. The kernel starts the first system process, which is new, and that's systemd. Systemd takes over. It reads the configuration files from etc systemd directory, and there is a etc systemd system default target. Brings the system to a state defined by the system target, typically what you used to call run level 3 or run level 5, and then lastly, it executes the RC local file, kind of like the Oracle Linux 6 boot used to do. A change. In Oracle Linux 6, Red Hat Linux 6, there was an init RAM disk that was available with each new kernel, because each new kernel was different, bigger, required a larger init RAM disk. Well, to make that kernel update RPM, or kernel install RPM, smaller, there's a new command called drawcut. And this command is used to read the running kernel and then create a RAM disk from the kernel that's running. And so the examples that we have up here we have a init RAM disk 38.98.7.1.EL7 Oracle's UEK image. And that corresponds to the VM LNZ 38.13.98.7.1. I mean, those are identical, okay? But instead of taking up the space for that, and it can be easily 15 to 30 meg, all right? And a new command, you have the list here for init RAM disk, init RD, to view the contents of what was created by drawcut. Now, notice that it's piped into less, all right? Very, very important. Once again, it'll scroll off the top of the screen. You really won't get a lot of information, all right? Because it'll go zip and be done. Master boot record. Today, it's still 512 bytes. When we get to the larger sector sizes that are now 4K on the larger hard disk, I'm not sure what's going to happen to this. But the 446 bytes are, for the most part, GRUB2. We then have a 64-byte partition table, and then the magic number is based upon something called an endian format. It has to do with the low order 2 bits of the low order byte. And there is a big endian, and there is a little endian. And so with Intel-based machines, this last 2 bytes here so in hexadecimal, it's AA55, all right? And if those aren't there, then the BIOS loading it considers it to be a bad master boot record, and it will not boot it, all right? And so once again, this is little, L-I-T-T-L-E, there we go, little endian, all right? And surprisingly enough, big endian is 0x55AA. All right, so you can tell a little difference between the two. And so Spark, Sun, Solaris, AIX, HPUX, and others are big endian, okay? Oracle Linux 7 uses GRUB2. This is an update. It's not boot GRUB, GRUB conf, or GRUB menu, or GRUB LST like it was in GRUB 1. It's now boot GRUB2, GRUB CFG. Do not edit this file directly, all right? What we want to do is we want to take the grub2-make config command to generate that command. And so there will be template files inside of etc grub.d, the directory. And there's also an etc default grub settings. You'll get to the lab or the practice, and we'll manage all of those environments for you and give you the chance to kick the tires and slam the doors so you get a good feel for what's there. So, in this boot grub2 grub.config file, there are things like grub timeout, a measurement in seconds, grub default, the default menu entry to boot, all right? And once again, you can have multiple menu entries, just like grub1, all right? And so you could have, 3 or 4 different kernels that you could actually pick, and you pick a default kernel for the one to boot. Yeah, real typically, it's 0, which means it's the very first one. Remember, we're computer scientists. We don't start counting with 1, we start counting with 0. Okay? And so you'll go in, make the corresponding changes in the etc default grub file. And so let me escape this screen here. And so here is etc default grub. Once again, just an ASCII text file. And so if 5 seconds, right there, 5 seconds, not enough for you, then you can go in and make it 6, 7, 8, 9, 10, whatever number you want, or living on the edge, you can make it less. Grub distributor, grub default, disabled, terminal output, command line, disable recovery, and there's others. All right, this is just a short list, okay? And so you'd make your changes here, and then you'll do a grub2-makeconfig-o boot grub2 grub.cfg. Now, there is a second page here, and so if you want some information that helps describe each one of these in a little more detail, you can certainly go take a look at that. All right. So in the /proc mount point from inside the init RAM disk, there is a command line file that contains the information with regards to the boot image that you booted. All right. So once again, 38139871 EL7 UEK3. Briefly, between a 100% Red Hat compatible kernel and Oracle's UEK3, UEK4 kernel, there's a couple of 100,000 changes that Oracle's kernel developers have made to enhance the performance of the Oracle stack running on top of Linux 6, Linux 7, and for that matter, even Linux 5. Here's the grub2 configuration file. While it has similar information to what was in the grub1 file, we now have something called a menu entry. And that then is numbered 0, 1, 2, 3, 4 for as many that are there. And then that then becomes, in this case, the kernel that was booted. So that would probably be number 0, which is the default. When the actual grub menu shows up, oh, it's not 0, it's 1. All right? And so typically, that's the 0 line, that's the 1 line, and that's the 2 line, okay? And so you would make the default number 1, all right, and then that's what gets booted. And so once again, you could have 5 or 6 menu entries and actually boot menu entry 3 if that's what you wanted. But give yourself enough time. 5 seconds may not be enough for the default. to be able to take the up and down arrows to allow you to move up or move down in this list to choose one of them. Now, let me back up a slide. If you read the bottom of the slide, it says you can use the E key to edit the selected item. And you can move up and down with the arrow keys to change the selected item. If you edit it, you'll get another screen where you can go in and make changes in real time. That's the good news. The bad news is the changes that you make here through this GRUB menu, editing option, are not persistent. And so if you made a change earlier, rebooted, didn't reboot, you booted into rescue mode just so you could boot the box to fix it, you have to know that once that box is booted, you got to go in and make that change permanent. All right, you don't make the change permanent, the box doesn't come back and reboot again. There is a command line with GRUB, and there's a whole series of commands that you can do. And so you can go in, you can think about it, you can give information, but once again, any change that you make is temporary, non-persistent. Now, this ends the material on the boot process and GRUB. The next section that we'll do actually gets into systemd. However, before we do that next component, let's give you a chance to get up and walk around and take a very, very short break. All right, welcome back. As I mentioned earlier, systemd is a replacement for init, for init. All right. And what systemd really does, it enables some parallel processing during the boot process to take that process that used to be this long and shorten it. All right, that's the intent. Okay. Now, in 6, Mark Shuttleworth and the folks at Conical had come out with Upstart. And so both Red Hat and Oracle were using Conical's Upstart as the default initialization for the init process as it booted. However, several years ago, Mark looked at both the work Conical was doing and the work Red Hat was doing, and he said, time out. We both don't need to be doing this. And he said, I'm more than willing to use the work that Red Hat is doing. And so while we used Conical's Upstart during 6, as we get to 7 now, we're going to use Red Hat's systemd. Okay? It's the first process that starts. It speeds up booting by loading services in parallel. That's that fancy word there, concurrently. All right? And it allows you to manage various types of units on the system. There are services, targets, devices, file system mount points, and network sockets. All right? And so all of those are available for you to set up inside systemd. And obviously the very first one, services. We've had services in 6, but they were serially started. And so I guess it was in 2010, Red Hat released in that Sandy Bridge chipset the ability to have 2 parallel threads per core. And some of you have got, 64 cores or 128 cores. And so you've got 128 to 256 parallel threads that you can use to speed up the boot process. Okay? Well, now, this is an old-time computer person, been in the computer business for 40 years. And if you're only booting your Linux box once every 6 months, once a year, speeding it up, I'm not sure that that helps a lot. All right? Not like you're doing it every hour. Now, yes, we will do it every hour in the lab. Okay? But back at work, you have production machines that haven't been rebooted in a while. And if you're on Oracle support with Ksplice, you can put on critical kernel patches without having to reboot. So while this helps, it very much speeds up the process. It's not something that you do, or shouldn't be something that you do regularly. So services are started in parallel, and by using the socket-based activation and the display bus. All right. Daemons can be started on demand. Processes are tracked using control groups. That'll be one of our later lectures in the course. Snapshotting of the system state and restoration of system state from a snapshot are supported, and mount points can be configured as systemd targets. So, to accompany systemd, there's now a systemctl command. All right? Do a which on systemctl when you get to the lab. I will show you that in the lab. And it will give you a directory. And then if you'll search that directory for *GRUB CTL, you'll find there's a lot of CTL programs. And those are all new with systemd. And so we cover the systemctl because it's critical, prominent, okay? And so the first box, the fourth bullet, I can list the units, type, service, all right? I can list the unit files, type, service, and then I can also go out and find what other types. Remember, we had a listing of services, targets, devices, file system mount points, and sockets. So all of those can be individually listed. We just picked the one here that's probably the most common. Okay. Here, we've used the systemctl command to actually ask what is the status of the HTTPD daemon, all right? And it gives me information about it being up and running. Now, is active obviously means that it's running. Is enabled means that on reboot is this particular service enabled to start on reboot. Okay? And you had similar activity in Linux 6. You had a CK check config command that allowed you to go out and either turn on or turn off an individual service from starting on reboot. So I would like to tell you that this is OL6. This is OL7. And so remember the service name start command that you had in OL6? It's now systemctl start name. And there's a stop name. If that particular service allows for a restart, there's a restart, there's a try restart, there's a reload, and there's a status. All right? And once again, all of those have parallels to Oracle Linux 6. And then the operator down here at the bottom, system list units -- type status all. So what I want to do is I want to see all of the service types. Okay? Now, previously, we were doing list service all as well. All right? Once again, you might want to pipe that into less. All right? I think you'll find that the list is quite voluminous. All right? That would be my expectation. All right? Check config. That was the command I mentioned in 6. All right? So this is 6. That's 7. And so you would do a check config name SSHD on. Name off. List name or list with no qualifier. And you once again want to pipe that into less. And so the enable here mimics the on. The disable mimics the off. And so on reboot, if you're disabled, it does not start. There are two directories, all right? There's a user lib systemd system, and then the files are some name file.service. And so this is the DHCP D daemon. And what we do is we copy that into a working directory /etc etc /systemd/system/ same file name. So dhcpd.service. You can go in that etc systemd services directory, edit the file, make a change, and then you can go back in and re-enable, which creates the appropriate link files to be able to have it start on reboot. All right. Now, you may have done a systemctl stop, then dhcpd. And so if I do the enable, then I may need to follow that with a start. Okay, once again, depend upon the steps that you've taken. Now, target units. There are still 7 run units. Start with 0, end with 6. All right? And so those are the same run units in Linux 6. And so 0, power off. 6, reboot, just like it was in 6. All right? And so in the user lib systemd system run level files, you should find 7 of them for targets. All right? And you will have one that is a default target. Now, the only sorta change has to do with run levels 2, 3, and 4. Previously, 2 set up a multi-user without NFS. 4 would set up a multi-user graphical without NFS. So today, 2 and 4 still are multi-user, but they're all non-graphical, like run level 3. And so what we typically see, either a Solaris style run level 3, because Solaris does not really have a GUI, doesn't have a run level 5, or we have a run level 5. All right, so those are really the two choices. One is an oops, all right? You were just editing something and you didn't edit it properly, and now you've got a box that won't boot. So you'll get into rescue mode, all right? Fix what you need, get the box booted, go correct your typo, all right? That way, remember, anything you do in rescue mode is forgotten. You actually got to get the box booted. So as you go through the rescue stuff and you're trying to figure out how to get the box up, you know, nothing worse than telling your boss, well, I can't get the box up, you know. Now, systemctl, get default, and it tells me I'm doing run level 5, a graphical target. Systemctl list units type target. Okay, list the current active targets. And so, once again, if I'm listing the actives, all right, that lets me know which ones I have set up to be bootable images. Here, we have gone in and with the set default, we've changed from graphical target to multi-user. Once again, that's kind of like run level 3. Okay. So the default is now 3, and to implement that fault, to change its configuration, you'll use the isolate command. And once again, all of these steps will be worked through as you get into the practice. This is what I refer to as the oops. Okay. Now, previously, this was single user. And so you get into single user, the box is booted, you can make changes that are preserved, okay? And then, if it did not get what you wanted, you can fix it. So there's a rescue mode. There's also an emergency mode. It allows you to attempt repairs. Because, I mean, you have a whole bunch of mount points. Some of them could be NFS mount points. Well, what if the NFS server is down? That will not be a good day. But nonetheless, it's something that you have to be prepared for. You still need to be able to get that box up. Okay? And so once all of that is done, you've got to be able to reboot and get the box back up. Now, lastly, in 6, when we would get into what was at that point in time a rescue mode environment, I don't think we really called it emergency. You weren't prompted for the root password. And a lot of folks consider that to be a security liability. Obviously, that liability has been closed in Linux 7. Halt, power off, reboot, suspend, hibernate, and suspend hybrid. And so I'm not so sure that the last three down here are appropriate for a Linux server running some sort of Oracle stack software. But a halt, a power off, or a reboot, once again, issued through the systemctl command, helps me get my box down and back up. All right, so those were the topics that we covered. And like a lot of lessons, we have quizzes. And so which of the following file must you edit to define persistent kernel boot parameters? I'll give you just a few moments here before I get into the notes pages to let you see what the answer is. Did you get letter C? etc default grub, certainly what we talked about during the lecture. Next quiz, which of the following statements are true about systemd? It is the System and Services Manager in Oracle Linux 7. It is backward compatible with the System 5 init scripts. It provides management of services, devices, file system mount points and sockets. Boy, I had a slide that told you that precisely. And it runs as the first process. So, is it one of those individually, or is it all of the above? Let me give you a few moments here. And so it's all of the above, letter E. Lastly, which of the following statements are true about the systemctl command? The systemctl start for a particular service command causes the name service to start at boot. No, that's an enable command. Oh, letter B. The systemctl is active command checks whether the service is configured to start at boot. No, is active is active. And so there are two answers here. Which ones? A and C or B and D? B and D. All right. The practice overview here is that we're going to play with GRUB2. Let you work with the bootloader. We're going to boot different kernels. We have several different kernels installed on your box. We'll use the GRUB2 menu. And then lastly, we'll play with systemd and systemctl. All right. So we'll do lecture 4 when you get through with practice 3. See you in a minute. Well, welcome back. This is the practices for lesson 3. We're going to take and explore obviously the boot process, and we're going to do a little bit with systemd, the replacement for the init process. And so let's go over here like we did with lesson 2. (3.1) will be exploring GRUB2. 3.2 will have booting different kernels. And so we do have a UEKCK available. No, start again. We have an RHCK, a Red Hat compatible kernel. We'll use a GRUB2 menu. We'll explore systemd units. And then lastly, we'll work with systemd target and service units. Okay. Take the better part of an hour or a little more. So GRUB2 configuration files, where we had to move those around. We'll boot into rescue mode and repair an initial RAM disk image, being sure you have the correct kernel booted. We'll use the GRUB2 menu to modify kernel boot parameters. We'll do systemd units, target units, default target units, change the default target unit, view all service units, and configure a service to start and stop at a specific target state. So 3.1, so kind of move that over just a little bit. There we go. All right, so you are root on Dome 0, host 02 is up and running. And so back here, and so I'm root, and this is host 02 that's running. All right, we would have shut down host 01 after we did the install. Okay. And so we want to SSH over to host 02. And once again, I'm going to use that other window, that other tab that I have here. Password is Oracle. And so who am I? Root. Where am I? /root. And what's my host name? Host 02. That seems to meet the requirements. Okay. We want to do a df-h, and so it confirms what is actually mounted. Okay. df-h. And so we have a root, we have a boot, a dev, a run, and then a run user 42 and a run user 0. Okay. And so those are my mounted partitions. Oh, come here. And so we want to take a look at what is in the boot 2, or the boot directory in GRUB2. All right. And so an ls boot GRUB2. And so device maps, font is a directory, grub.cfg as a file, grub env environment, and then an i386-pc, a locale, and themes. Alrighty. And so what we want to do is we want to take the less command to go out and actually view the grub.cfg. All right. So let's do and the very first thing you need to see at the very top says, do not edit this file. All right. It is automatically generated by the grub2 make config. We did that during the lecture. All right. Using templates from the etc grub.d directory and from the etc default grub. All right. And so there is some information here with regards to the begin. Whoops, 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 whoops. And so now we're at the end of the header section. And so right beneath that is the tuned. All right, and set tune params to be nothing. We're at the end of the tuned section. The next one here is the grub01 users. and we have set superusers to be root. All right, export superusers, okay. And then password underscore pbkdf2 root. And then the dollar open curly, grub2 password, close curly. Okay. Moving on down, we have a begin for grub.d for 10 underscore Linux. All right, and once again, the files in the grub.d directory are handled in lexicographical order. Okay, and it's that 10 underscore Linux that has the menu entries that allow us to see what are the bootable kernels. And so we have a 3.10.0 kernel, which is specified here, and that is an RHCK kernel. So that's a Red Hat 100% compatible kernel. Okay. There is some information with regard to it. Now, I'm going to cheat. We're going to do and so there is a menu entry here for 7.2, the 3.10.0. All right. The next one down is the 3.8.13.118, which is the actual bootable kernel that we had up there a moment ago. I'm going to press the letter N, as in next. And so we have a 3.10.327 kernel. All right. We then have a 3.8.13.98 kernel, which is a different patch level than the 1.18 kernel that we were running earlier. Okay. And then last but not least, we have the Linux server rescue bootable kernel and its corresponding universal unique identifier, UUID. All right. And then we have some additional begin ends. Okay. So that's the file, and then these are all the menu entries that I searched for. Okay. And so to get out of less, we'll do a Q for quit. All right, so we're back to a prompt. So what we're going to take is the grep, and we're going to look for menu entry. And once again, there's going to be a caret at the beginning because we want the menu entry that is at the front of the line. Remember, it actually showed up in a couple of different places. And so there are the menu entries at the beginning of the line. And so once again, there was the 3.10.0 patch 327. Then there was the 3.8.13 patch 118 UEK. Then the 3.10.327. But this time it didn't have the .4.5. As further components to the patch. All right. Then we have the 3.8.13.98. And then lastly, we have the rescue kernel. All right. And so those are the ones that we're actually going to look for. And 1, 2, 3, 4, 5. Those are the same 5 that are actually in your book. All right. If we go out here and take a look at boot for VM Linux, we should find some corresponding numbers that exactly manage those menu entries. All right, so we'll go back here. We'll clear ls boot. Sure enough, there's the 310.27, 327, 4.5, 27.el7, the 38.13.118, and the 38.13.98. So those are the same 5 bootable kernels. Now, in addition to the init RAM, to the VM LNZ, there is a and surprise, surprise, there are 5 of those init RAM disks, and they correspond exactly to the 5 bootable kernels. And so that's the init RAM disk, RAM file systems here. You might also see some init RAM kdump image files. These are special files created by the kdump mechanism. We didn't have any. So a uname -r here shows that we're running the 3813. How about a 3 instead of a 1? You think that'll make a lot of difference? There we go. And once again, I didn't have to type it all in because I knew that the number that I was looking for was the 318.25 EL7 UEK. All right, and so once again, that's the one that's there. That's the one that is available. Okay. Now, what has been shown has been the entire line that is associated with the Linux 16 entry here. All right. These same entries appear in a file, cat proc command line. And so you take that line and kind of superimpose it with the line above, and surprise, surprise, they are very much the same. Okay, that's what we're getting out of both of those two. And that should take us over to booting different kernels. All right, and so the current kernel is the 18.205, and that menu entry here is menu entry number 2. Okay, and so use the VI editor to change the GRUB default entry in etc default GRUB from saved to 0. All right, cp etc default GRUB And so we're going to take this one line that says default, and I'm going to do a $. I'm going to append a 0. and then I'm going to do an escape :WQ. All right, and so we've made that save. No. And so we now want to do this grub2 make config for this new grub.cfg file. Okay. All right, and so now what we've done is we have a different image with the init RAM disk associated with it. And we want to take the systemctl reboot. Now my window's going to go away here. Okay, oh, it already has. And so we're now back. And so we're going down. We're on our way coming back up. We're there. Well, maybe not yet. Patience. It was blocked and now it's still running. Trying to get everything up and going. That's better. Let's see if we get some better results. Look at that. And so we want to now go back and see which kernel we actually have running. All right. And so the 3.10.0.127.4.5 is the very first menu kernel that was in that grub.conf file. And once again, because we are computer scientists, we don't start counting with 1, we start counting with 0. That's why you changed it to be the 0 bootable kernel. Okay. Now we want to go back and edit the default grub and take the timeout from 5 seconds to 60 seconds so we can have a chance to play with the grub menu. All right. And so the grub timeout had been 5, so we'll make that 60. We have to run this make config again. So we added the 60. We did the make config. And we're going to use the move command to move the init RAM disk for the Red Hat compatible kernel into root's user home directory. All right. And so we'll take the boot RAM disk for 310, 327. We're going to put it in root's home, okay? So mv boot and tilde puts it in root's home directory. And there it is. All right, not a problem. And so we want to do, once again, another systemctl reboot. All right. Well, then, once again, reconnect, this time with VNC Viewer. Okay. Now, I'm going to give you a brand new command for step number 2 here under letter E. So let's go ahead and get the reboot started. That will take just a few moments. Control R, systemctl reboot. And so once again, it pretty quickly blows me away. All right. Which is kind of what you would expect. All right. And once again, we went down, we're running. It's going to come back up here in a few minutes. And so I need for it to be blocked first. It'll be that way in just a moment. Maybe a moment more. Okay. Let's see what happens. All right, this is a brand new command. And it has to do with the fact that we updated the OVS server. And so here, I've now got 60 seconds to scroll up and down through the list. All right. And once again, that was a byproduct of me having changed the timeout from a very, very brief 5 seconds to 60 seconds. So I'll go back up here. We'll pick this kernel, and it's going to upchuck and die. All right. And the reason that it upchuck and die is that that image file is not there. All right. GRUB2 menu appears with the 327 kernel selected. And once again, I moved up and down so that we would stop. So here, I've suspended the process by moving up and down. And so we have gotten to this point where the file is not found. And so what we need to do is we need to press any key to continue. And once again, don't get cute about what is any key. All right. Really? I guess I just didn't get there fast enough, huh? Went down. So we really do expect it to reboot. Oh, that's what we wanted it to do. Reboot. So cool. So CD. And so what we want to do now, seeing as I did press any key and it went away just like it was supposed to do, I believe we want to go here and choose boot the rescue kernel and repair the initial RAM disk. Use the destroy command, although they might already be shut down. If so, domain does not exist. We changed into the host 02 directory, and I recalled the create command, the start command. And then we connected with the NC viewer. Okay. And the 310 kernel was the one that was selected. And I then moved down the list to the rescue kernel. All right, haven't started it yet. And so we'll go back over here. We'll press enter. There we go. There's like an L7 there for Linux 7. Okay. We'll sign on as Oracle. Password is Oracle. The Oracle student window shows in, the password's Oracle. We signed on. We're now going to do a substitute user dash. Once again, the password here is Oracle, and we're going to get the actual kernel that is running here in rescue mode. And so the 310.327.el17.x8664. And once again, that corresponds to what is in your book. All right. And so I look for the init RAM disk there for the 310. All right. But the other RAM disk, the 327.45, is missing. And if you change the boot directory and you do a list, if you change to the root directory, the file that is missing is over there in root. And so if we go to CD to boot, so pwd, ls, there it is, cd to boot. And so I now want to take the, and I think the pronunciation, like I told you during the lecture, is DR, a draw cut. All right. Dracut, maybe? I don't know. I'll let you contemplate that. All right. And so we want to so 310.327.45EL7.x8664 IMG file. All right, so we're going to press enter. Then we'll let draw cut go out and work its magic. Okay. It will take a few minutes. I will pause the recording and I'll be right back. There we go. I was gone for a minute or so. All right. And now there is this new 4.5 EL7 init RAM disk. All right, so draw cut has been successful. And so the list init RAM disk for init 310 blah 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 and pipe it into less. And so the new RAM disk image here is the one that we're looking at. Its size is 32 meg. All right. These are the arguments to it. And once again, it gives you the current version of DrawCut as well. All right. And so there's a lot of information there to make that happen. Okay. And once again, I'm not going to scroll down through it. Please feel more than free to if you want to. I'm going to do a Q to quit. If we go back here and do the grep for menu entry, all right, and once again, what we're looking for is the very first entry here, which would be letter 0, okay. The newest UEK kernel in this example is listed 3rd. This is the kernel that you want to boot, all right. So let's go do that grep. Let's see here. How about Control R? There we go. And so there are my 5 menu entries, starting with the 327, and the third one down is the 3813 11825. All right. This is the kernel that you want to boot. Okay. And so we want to go from default 0, which is 1, to default 2, which is 3. And then we want to make this grub again. And so I'm going to go here and Control R, VI. And we're going to make the default here 3. Escape :WQ. Control R for MK config. That's cool. That's it. There we go. All right. Done. Okay. We're now ready to do a reboot to boot that new kernel in. Okay. And so that should now be the kernel that will come up. So once again, Control R, systemctl reboot, and it goes away, just kind of like you'd expect it to go away. There we are. Now, because we did a reboot, our expectations here is that host 02 shows up. It is running, and once again, I'm going to pause the screen. All right, let's resume and connect again. And so there is, what did I put in there? Yeah, I put in 3, didn't I, instead of 2? How dumb was that? We'll go ahead and boot and go fix it. There's that L7 again. My bad. But the obvious piece of this is that it's not that hard to fix a screw up. All right. And once again, I do good at having screw ups. All right. There we go. The right kernel is selected. It's amazing what happens when you enter the right number, right? And so I'm going to go ahead and press enter. We'll take that kernel, and I apologize for getting it wrong. Obviously, I knew better, because the minute it came up, I knew that wasn't right. Well, look at that. We actually get a real boot menu. Isn't that pretty neat? Okay. Before, we got just a whole bunch of other commands that were seen on the screen as we were trying to get into rescue mode. All right. And so there we go. Got a full screen. Just a moment here. We're going to have the Oracle student. Okay. And so we've done the reboot. We've chosen that kernel. I've signed on as Oracle. I'm going to sign in as root, and we're going to confirm that we've got the 118.2.5 kernel. One more time. See, we're done. How about that? That's not too bad. Okay. And so the UEK EL7 is now loaded. So we've done 3.1, 3.2. This is now 3.3. And so we want to take the systemctl command and do a get default. All right. And we're going to run a run level command. In fact, I'm going to show you two commands. All right. So systemctl get def get default. That's not an underscore, that's a hyphen. Makes all the, so our target is that. Run level, though, shows that we're at run level 5. The POSIX equivalent is who-r, which also confirms that we're at run level 5. Okay. And so what we want to do is we want to reboot. All right. You're going to get connected once again. And then we're going to go in and we're going to take this line that was the bootable kernel. All right. And we'll edit the bootable kernel entry to boot into rescue mode. Rescue mode is the same as the single user mode. You'll use the up and down arrows if necessary to highlight the 3.8.13 entry. Okay. And so we'll go out and we'll make some changes. That's the intent of this particular piece. And so we've already turned we're at run level 5, so Control R, systemctl, reboot, there we go. Then it goes. There we are. So we did the reboot. We then brought up this screen here, and that was the kernel that was highlighted. And so each entry in the GRUB2 menu is associated with a menu entry. Edit the bootable kernel entry to boot into rescue mode. The rescue mode is the same as single user mode. So use the up and down arrows if necessary to highlight the particular entry here of 3, 8, etc. You then want to press the letter E. That is the letter for the word edit. Okay. And so that's the kernel that I want. And so I'm going to press the letter E to edit, and then that brings a screen up that looks very much like this screen here. All right, I mean, and there it is. And so the code associated with the UEK kernel from the GRUB file is displayed. Use the arrow keys to position your cursor at the end of the Linux 6.16 line that is shown. All right, and so we have the ability here to move down through the line, and notice that we're ready to do a press Control X to start or Control C for a command prompt. And so let's go back here. So we want this line here where we have the Red Hat graphical boot, but currently it is listed at quiet. Okay, and so we want to be at the end, right after the word quiet. Okay, and so that's what we see here. And so we've had to come down much further. And so this is the screen that I'm on right here, this little black set of bars. Now, we have some typos. This is correct systemd unit. This should say systemd unit, but it does not. All right. And so the systemd.unit equals run level some number. It could be run level 1. All right, single user as my target. We could also use the 1 or the little s, the big S, to the word single. All right. Or we could say rescue target. Once again, that should be systemd, and it's not. And so that specifies the target for a multi-user non-graphical interface. The letter B, emergency, specifies emergency mode. All right. Now what we want is on the next page, and it's simple. Single, S-I-N-G-L-E. We'll press Control plus X to accept your change and continue the boot process. S-I-N-G-L-E. All right. And then down here it says Control X to start. And what you'll see here is the boot process proceeds until you get Welcome to Rescue Mode screen. All right. Kind of down here at the bottom. We're not quite there yet. There we go. you notice it says welcome to rescue mode, just kind of like that screen did a moment ago. All right, and so give the root password for maintenance, or type Control D to continue. And so to view the different options available from the rescue mode, systemctl default, Control D, journal control -XB are system reboot. Okay. And so what we want to do here is to actually type in the word Oracle and then run that same run level command again. Okay. And so ORACLE. And so run level is 1. Who dash is also run level 1. Okay. System CTL network. Now, one of the things in single user mode, you have no network. All right, it's just you and the box. You're one with the box. All right, and because there is no network, that nobody else can connect to your box. And so obviously this is not something that you want to do in the middle of the day. All right, but you shouldn't be making changes and rebooting the box in the middle of the day anyway. You just shouldn't. Okay. So we did the status for the network. Tells us it's dead. If we do the get default, and once again we've done that before, and it's graphical target. Graphical target. That looks good for me. Now, what I'm doing, we have the ability to search from bottom backwards through the bash_history file. And so I press the two keys together, Control R. That allows me to enter some search criteria. And if the first thing that comes up isn't what I want, I press Control R a second time to bring the additional entries up. Okay. And so bring the system from rescue mode to the default system state. You'll press Control D to exit rescue mode and continue the boot process. All right. The GNOME window should show up. All right. We'll sign on as Oracle, and then we'll go check a nuance, a difference here in the run level command, and we'll show that to you. All right. And so if I go back here, do a Control D. Control D is also sometimes an exit or a quit from the keyboard. Now look at that. It's 1 in 5. Now it says it's a system command, but it certainly can be run as a non-system user because it's a query command. It's not a command that will make any sort of changes. Okay. All right. There is a run level, which is the current run level, and then there is the previous run level. And so when we ran the run level command previously, there was an N followed by a numeral. The previous run level, if it is the letter N, or it could be the letter S, depending upon how you configure the end of line command. The N stands for none. Obviously, the S would stand for single user. Alrighty. And then the current run level being that we were using the graphical target, that current run level is run level 5. And so once again, the -R in the who command print the current run level. It doesn't really have a notion of a previous run level. Oh, it doesn't tell you. Hold on. No, it doesn't tell you here either. Well, that was a nice idea, Al. The answer is who-R is specified by the IEEE as being POSIX compliant, all right, where the run level command is just an operating system command. We'll do a Q to get out, all right. So when you have a previous, it's the previous run level number, or it's the letter N, which signifies none, and I've also seen it with the letter S. And so instead of typing in the word single, had I typed in just the capital letter S, then my expectation would have been that the previous run level here was an S instead of a 1. But whether it's an S, whether it's a 1, it's still single user mode. And as you can see, there was no network. All right, there was nothing like that. Now, to enter the rescue mode from the shell, you must do a systemctl rescue. Now, this is going to change the state. All right, and so notice that it does need to be a privileged user. And so su-oracle and so what will come up, welcome to the emergency mode. After logging in, type journal-xb to view the system logs. Use systemctl to reboot. System default or control D to boot into the default mode. Give the root password for maintenance. Okay, so we're just going to press System D to exit the rescue mode and continue the boot process here. Takes me back to the Oracle student prompt. Right click, open terminal, su-oracle, and so who am I? I'm root. I'm in the root directory, and this happens to be host 02. And so we've gone back down, and our current run level is once again 1 and 5. Why? Because we went into rescue mode. Okay, single user mode. All right, I think we're done. Oh yeah, look at that. So we're now down to 3, 4. We will view some systemd units. Displayed sample output may not match. The assumption is you are the root user and you are on host 02. So we're going to list unit files here, but I'm not going to run that precise command. All right, for a reason. All right, for a reason. Let's bring that up to the top of the screen. And so systemctl list unit files. Once again, those are all supposed to be hyphens. There are no underscores. But I'm going to pipe this into word count. All right. And that's because there's 731 of them. All right. Now, you don't need to use the vertical pipe nor the word count command. I mean, if you want to scroll down through, they're just going to go zip off the top of your screen. And so they're going to run through very, very quickly. All right. Note the different types of systemd units. Auto mount provides auto mount capabilities. There's a mount, there's a scope. And so tell you what let's do. Let's pipe this now into less. And let's search for auto mount. And so there's the one, auto mount. If I press the letter N, it comes back and tells me, I'm sorry, that's the only one. Okay. And so the next one, come here, was mount. And look at that, there's a couple of mounts. All right, now once again, we also brought up mount with auto, all right. If I press once again the letter N, it's a next. Oh, there are some more down here, all right. And so 368, there's some blank lines, all right. And so let's do a letter G. All right, that takes me all the way back up to the top. There we go. That kind of didn't do precisely what I wanted, but that's okay. Let's try that. There we go. Cleared the search criteria from before. All right. They want to do scope. And so there's one scope here for session 2. All right. If I do next, no, there's only one scope. So we saw that there's one auto mount. There were a whole bunch of mounts. There's only one scope. Okay. And so if we were to take a look, we've done these 3 here. But on the top of the next page, there's service, slice, socket, target, timer, device, snapshot, swap, path. And so if we take list units type auto mount, then once again, what we should bring up is just that one loaded unit. So let's take this command here. Now, if you want to look at the other ones, it's in less, go search for it. You know, once again, I'm not going to run through all of this. It gets to be just a tad bit redundant. All right. So I'm going to do a Q and get out. And so let's bring up list units type auto mount, and it tells me one loaded unit listed. All right, type auto mount. All right. Now notice that it's only listed 1 through 9, line 9. That means we're done. And so I'm going to press Q to get out. And now if we went for scope, once again, there's only one scope. Now, I didn't go pick mount, folks, because there were a lot of mounts. All right. And so one loaded unit listed, pass all to see all loaded, but in active units too. All right. So once again, there is more information that can come from this command as you go through and take a look. Now, what they wanted us to do was to take the auto mount. and show all the units, and the answer is that's it. There were no more. All right, and so I'll get risky here. Let's close that. And once again, all we had was the one scope. And that's because I've not had much signed on since this machine rebooted, all right? And so I would tell you that probably has to do with it says it too there. Session 2 scope loaded active, running session 2 of user Oracle. And that was who signed on. That would be my expectation, although we have done a substitute user over to root. Okay. We know that there will be more units here for mount. All right. And I guess I could have found 12 listings altogether. And here, with the mount all, we actually pick up a couple more. I'll let you run those commands. All right. We explored the scope, and that was it. One user, and that user was Oracle. All right. And we tried to list it all, but once again, all we had was Oracle. So there's not a lot there. All right. They're just, because why? Because all I have signed on is one user, and that user is Oracle. Okay. Now, if we went for slice, the slice command will list the current active slice units on your system. And so, tell you what, let's do that so we can at least talk about what the slices are that are there. And so we've got a get TTY. We have a system slice. We have a user 1000 slice, which happens to be Oracle. A grep for Oracle out of Etsy password shows me that Oracle's user ID is 1000. And so the user slice there is, once again, Oracle. And then the user slice loaded with the active user and session slice. Okay. And so the very first one, dash.slice, is the default slice. It's the root slice. And literally that's the top of the tree. I guess that's really the root of the tree because the tree's upside down. Slice all has the same number. I'm not going to do that for you. Socket shows that we've got 14 sockets listed here. And once again, sockets are network port numbers that these individual processes are connected to. All right. Same thing, we're going to pick up a couple more with sockets all. And once again, I don't think that that's overly exciting. We have timer and timer all. Once again, I'll let you list those and go through it. System CTL, list units type device. And we have 24 loaded units listed. All right. Device all, there's 47. All right. Snapshot units, there's none of those because we haven't really gotten to the lab where we use Snapper, okay, which is a new utility in Oracle Linux 7. None loaded. Snapshot all, once again, none loaded. Swap. Yeah. Let's do swap. All right. And as we expected, there'd be one unit loaded. If we had additional files here, We don't have 2 like in the book. We actually have 6. And I typed that correctly too, so I didn't screw that up. Okay. Systemctl path. All right, and path all. Okay. And that's the last one on the list. Okay. And so once again, all of these are different pieces and parts that you may not have seen in Oracle Linux 6 using Upstart, where they are part of Oracle Linux 7 now using systemd. All right, working with systemd target and service units. All right, and so if we look at what the targets are, we've already done a get default. All right, and so we're going to take a look here at type target. Okay, and once again, there could be 16 of them. Now, in this case, it gave me lines 1 through 23. Well, I'll tell you what, let's do. Let's take this guy, move him up. There we go. We got a little bit more. All right. 19 units listed. Do a Q to quit. Let's bring that command back. There we go. Now, instead of getting the numbers here that were 16 loaded units, we got 19. And so as you compared the list there, basic, crypt setup, get TTY, graphical, local file system, local file system, multi-user, network online, network, NFS, NSS user lookup. Now I don't have that one here. All right. May have something to do with LDAP, which we'll do in lesson 10. All right. Paths, remote, remote FS, slices, socket swap, sysinit, and timer. And so the NS user, the remote FS, all right, those get me extra ones, all right. That's where it came from. They want you to run it again with the all option, and this time we're going to bring up more. And once again, that's going to roll off the screen, and you've got to press the space bar to advance. Now, we did the get default command from before. And so let's do a Control R. There it is. Get default, the graphical target is our default. Okay, and that's kind of what we expected to get, the graphical target. And so if we went into the etc system default dash target, we'd notice that this default target actually is the live system. No, that's got to be systemd. That's got to be a typo. Let me go confirm. All right. Yeah, that was a typo. It should be etc systemd system. Okay. Well, they missed a lot of D's. Okay. The rum level. It's a little early yet in the day for that, but maybe later. All right. Now, the next piece of this is to change the default, all right, from multi-user, to set the default to be multi-user. All right. And so systemctl set default multi-user target. All right. And so we removed the symlink from the default, and we pushed it over to multi-user. Okay. If we took the etc systemd system default.target, it should now point at multi-user. And so an ls-l here for etc systemd system default target, and you now notice it points to not a graphical target, but to the multi-user target. And so once again, current run level is run level 5, but we can take my systemctl command and I can do an isolate root Oracle. All right, and so run level previously was run level 5, and now we're at run level 3, which is exactly what you would expect. Okay, not a problem. Okay, and so what I believe they want us to do here is to isolate again to be graphical target. All right, the get default is still multi-user. All right, the run level is 3.5, and so let's do an isolate to graphical user. And you can immediately tell that the screen jumped in size, and no longer am I at a prompt. I'm going to put in Oracle user. Password is Oracle. And so we're now back to 5. The previous run level had been 3. And even though the default is the multi-user target, we're actually right now at run level 5. And so we could do a set default There we go. And when the box reboots, it's going to come back up as a graphical target. Now, a discussion, probably worthwhile. We had it during the lecture. Yes, there is some additional overhead running a graphical target than there is a multi-user target. And so if you came from a Solaris background, they're pretty much just a run level 3. They don't really have a run level 5 that they can acknowledge. All right, they just don't. Okay, and so while it's a nice idea, no, they don't have it. And so we just did that set default. The files got copied. All right, the run level is still 1 and 5. Well, maybe I ought to catch up. What do you think? Isolate graphical puts us back. All right, get default. We reset that to set default. All right, type service. All right, so list units, type service, and once again there are 58. If we type in all, then we get a much greater number. Once again, I'll let you peruse that list. All right. If we do a systemctl status ATD, all right, this is the AT daemon. It's loaded and it's running, and so this allows me to run a job at 3 p.m. tomorrow. All right, I mean that's kind of what the AT command is all about. Continuing down the list, systemctl is active the iSCSI daemon, and once again obviously it tells me that it is inactive. So systemctl is active iSCSID. It's inactive. But when we take a look for cups, cups is active. Now what active tells me is that on reboot it will start. No, it is active tells me that it is up and running. Okay. The next one that we would ask about is enabled. ENAB, enabled. And it's disabled. And so iSCSID won't start on reboot because it is not enabled. But once again, if we check for cups, then it is enabled, and the expectation would be that the next time the box reboots, cups will start. Okay? And so, apologize for the door chime. All right. Is enabled, and it's not. All right. And so status is, it's inactive. And so start iSCSI. And it now comes back and tells me that yes, it is active. Okay. We can also get the status command that will tell me some very similar information in that it is active, it is running, but because it's not enabled, it won't restart when the box reboots. And so we need to take the is enabled? No. And so we will go out and we will enable it. All right. And so we now ask, is it enabled? And it tells me it's available on reboot. All right. And so now the status is it's loaded and it's active. All right. And so if we were to take a look at etc system multi-user target wants, then we would have a whole list of things that are there. What I probably would have done is I probably would have grepped now for iSCSI service, because it's going to be part of the wants. It was not there before, but it is there now. Okay. Now, we don't necessarily have a need for iSCSI at this particular point. And so back here, disable. Disable. Stop. All right. It's inactive and it's dead. All right. It does look like it had a PID, and then we came back and we failed to read the PID from the file. All right. Started, stopping, stopped. OpenSCSI. All right. And so it went away. It's kind of as we expected it to. All right. It is inactive, is disabled, and we're done. All right. I think that's it. Let's close up 3. Let's go here to 4. All right. There's a lot of things to do in 4. 4.1, 4.2, 4.3, 4.4, 4.5, and 4.6. All right. This has to do with networking. And we have a lot of the network CTL or Network Manager TUI that we'll take a look at. Okay. And so we'll configure the ETH1 network by editing the configuration files. We'll use the GUI. Then we will configure network connections using the command line interface, the textual user interface, and then the IP utility to manage networks, and take a look at the address resolution protocol cache. All right, but first, you need to go and do another lecture from me that will cover some of these exact same things. So, I'll move us back up to here, and we'll do lecture 4 here in just a little bit. See you when you come back. Thanks.